Hello, everybody. I hope you're all doing well. This is the first page of this class kick where we're talking about all three of our hypothesis tests. So the first one that we learned about was the chi-square test for independence. We use this test to determine if two variables are independent or not. The second one is the chi-squared goodness of fit test. We use this test to see how closely one set of data fits with expected data. And the third one we learned about was the t-test. We use this test when we have two sets of data measuring the same thing. And remember, t-tests come in two different types. So there's the two-tailed test. This is when we're testing to see if there is a difference between two sets of data. We don't care what that difference is. It could be higher or lower, but just that there is a difference. And the second one is the one-tailed test. This is when we want to test if one data set is greater than or less than the other set of data. So let's see how this goes. In this first context right here, we're going to state which hypothesis test should be used and why. We're going to state the null and alternative hypotheses, and then you'll watch this video, which you are right now. Excellent. Number one says this: Benny rolls a die 90 times. Here are his results. Okay, now it doesn't give you anything more than this. Which hypothesis test should Benny use? Really, it seems like there's just one variable, one set of data right here, number on die. And when I look at my three hypothesis tests, the one variable one set of data is the goodness of fit right here. So I will put right here, goodness of fit, because there is only one set of data to analyze. And then the null hypothesis. Okay, so in goodness of fit, we're trying to see if the set of data satisfies a certain distribution. And for die, normally when you roll die, they're equally likely. There should be the same number of 1s, 2s, 3s, 4s, 5s, and 6s. So I'm going to say for my null, the number on the die. Sorry about that, folks. I wanted just to check to make sure I had my thinking right on this. So the null is that, yes, we are just expecting a uniform distribution. So the data satisfies a uniform distribution. And this is just a fancy way of saying that they are equally likely on each of the numbers right here. Equally likely satisfies uniform distribution. Our alternative hypothesis right here, folks, that would be if the die had something wrong with it, that it was an unfair die here. I will write down my alternative right here by saying it does not satisfy a uniform distribution. The data does not satisfy a uniform distribution. Something's iffy with that die if that alternative is true. Excellent. Okay, then question 2, 10 11-year-old students and 10 16-year-old students reported how many books they've read. Researchers wanted to see if older students generally read fewer books than younger students right here. Okay, it looks like we have two sets of data that are measuring the same thing here. And if that's true, two sets of data measuring the same thing, how many books are being read, then that would suggest the t-test right there. Okay, so we'll use the t-test because there are two sets of data measuring the same thing. Okay, null hypothesis for a t-test here is that there is no difference between the 11-year-olds and the 16-year-old reading amounts. There is no difference between the 11-year-old students and the 16-year-old students. I should make that a little bit better. Between the reading amounts, between the books read, between the number of books read, by the 11-year-old students and the 16-year-old students. Sorry, people. All right, there is no difference between the number of books read by 11-year-old students and the 16-year-old students. Excellent. The alternative here being, um, so remember the t-test, you can have two different types here. Um, and that is interesting. We are trying to see if the older students read less. So we're trying to see if this second data point right here, this second data list, we'll put a 2 right there and a 1 right there. The second data list is less than the first data list. That means that we'll definitely be using which one is it, the one-tailed or the two-tailed? One-tailed if we want to test if one data set is greater than or less than the other set of data. So we will be using, we will use the one-tailed, I'm going to make this font smaller, one-tailed t-test because there are two sets of data measuring the same thing, and we are trying to see if the second data set is, on average, less than the first. Okay, so the alternative then would be the amount of books read by the 16-year-old students is less than the amount of books read by the 11-year-old students. Okay, and finally, right here, we have Big Burger. Big Burger commissioned a survey asking people what their preferred type of burger was. Here are their results. Okay, we got chicken, beef, vegetarian, and we have ages right here. Right away, I see two variables that I want to see if they're independent or not. That tells me I don't even need to look, that I'm looking at a chi-squared. We will use a chi-squared order test for independence. I didn't spell that right. Independence. Because we want to know if two variables are independent or not. Null, super straightforward from our conversations in class. The preferred type of burger and the age of the survey respondent is independent or aren't. The preferred type of burger and the age of the survey respondent are independent. I'll say are independent. And then, yes, copy paste that because the alternative right here is the preferred type of burger and the age of the survey respondent are not independent. There is a relationship there. Okay, thank you very much, and I'll talk to you soon.